Okay, we're going to talk about quadratic application problems first. So the question here is really about understanding what you're finding and understanding what your equation represents. So in order to understand like what's the x variable and what's the y variable, you really have to read the problem and look at the data and understand what it's saying. So in the table, they labeled x and y, which is why I think it was probably simple for you to come up with your equation. You knew what to put in for x and you knew what to put in for y. But then when you read what's happening, it says that the data table shows various distances and heights of the basketball for each of her free throw shots. So I have to understand that the x is distance horizontally that the ball is going, and that the y is distance vertically. And so I'm actually going to sketch this little just like xy axis over here off to the side, and just remind myself that like if this is x and this is y, x is my horizontal distance from the shooter. So when she's shooting the ball, like here she is shooting the ball, and it's going to go like this. X is measuring this horizontal distance and y is measuring how high the ball is off the ground. And again, I don't just know that inherently. I have to read the question and look at the data and really process what x and y mean. And so then my y is the vertical height of the ball. So I'm going to label those things and just kind of draw this little arch to give me a picture. So I feel like that kind of helps. It's messy and kind of like elementary looking, but it helps just give me like a process and a picture of what's happening. So then when I read this problem and it says use your model from number 1, so my model is my equation, which I know is a downward facing parabola measuring these different things. And it says to predict the maximum height that Mrs. Doll's basketball reached. So when I think height, maximum height, I'm looking at the vertex of the parabola. And remember that vertex is made of an x coordinate and a y coordinate. And when I look at what I've labeled on my axes about what each thing's measure, the horizontal distance from the shooter is the x and the vertical height of the ball is y. When I read the question again and it says what's the maximum height that Miss Doll's basketball reaches, they're looking for the y coordinate of that vertex. Okay, so again, knowing which one's x and which one is y here is about understanding the context more thoroughly about what each is measuring in real life in this application. So then when I read number 3 and it says how far from Mrs. Doll was the basketball when the ball reached its maximum height, that's asking for the x coordinate because it wants to know a horizontal distance because it's asking how far from Mrs. Doll. I'm going to show you 2 more problems like this so you can understand what I'm saying about picking out the context, even if it's something that's not maybe super familiar to us, like throwing a ball. So these 2 problems are from Skill 4 homework. So you can go back and you can look at these. And in these problems, they gave you the equation. You didn't have to get the equation using regression and data, but it's the same type of idea. If you did have to use regression and data, you'd build this equation. And so basically here, if I reorder this a little bit, this is like a y equals negative 3t squared plus 73t plus 50. And this says the value of Jennifer's stock portfolio is given by this function, and V is the value of the portfolio in hundreds of dollars. So see how V is in the Y spot? So this Y is the value of the portfolio in hundreds of dollars. And then it says, and T is the time in months. So my X or my T is time in months. Again, I can make myself a little sketch here, like just maybe the first quadrant, and my X-axis and my Y-axis, and my X or my T here is time in months. My Y is the value of the portfolio. And when you're translating that back to like a real life scenario, don't forget that it's measured in hundreds of dollars. And this parabola has a lead coefficient of -3. So I know that it would be facing downward. So I'm just going to give myself a quick sketch of a downward facing parabola in this area. And that again just gives me the visual of what each axis is measuring with the parabola in the picture as well. So when I read the first question here, I'm going to call it part A. And it says, how much money did Jennifer start with? So it's asking how much money. The part of the equation here that was measuring money would not be time in months. Instead, that would be the value of the portfolio. So when I read that and it says how much money, I'm thinking in my head, I'm finding a Y. To find a Y, I must be given an X. So I'm going to finish reading the question and see if I can interpret the X correctly. And it says, how much money did Jennifer start with? So remember, X is time that's gone by in months. So starting would be 0 months. It would be the very beginning of the time that she invested the account. And so I would understand here that I have to plug in 0 for X in order to find Y. For part B, it says, when will the value of Jennifer's portfolio be at a maximum? So the question is when. So I'm supposed to find X, or T in this case, because I'm supposed to say in how many months will the value of Jennifer's portfolio be at a maximum. So I basically want to know in how many months does the maximum happen. So on my picture, I see the maximum as this point right here. And remember, that's made up of a T and a V, or an X and a Y, depending on if you want to use the problems the variable gave you, the variables that the problem gave you or not. So the X coordinate is the time in months, and the V is the actual value of the portfolio. It doesn't even ask me what the maximum value of the portfolio is. It just wants to know in how many months it reaches that, because it says when. So T is what I'm looking for to answer this question. So I'm looking for the X coordinate of the vertex. And so from that equation, I can either use my calculator to find the maximum point and take the X coordinate from that and translate it into months, or I can use the formula X equals negative B over 2A. But when I read this, I'm able to understand that I'm supposed to find X at the vertex due to kind of like dissecting the question and understanding which piece of information I'm looking for. I'm going to show you one more, and then if you want to see the actual solutions to these, go back to the Skill 4 homework solutions. I'm just trying to help you process X values versus Y values in these scenarios, since that was the struggle. So here's one more from the same skill homework, but this is just the next problem, number 5. So it says a textile manufacturer has daily production costs of, and then it gives this equation where C is the total cost. So my Y, or my C, is the total cost in dollars, and X is the number of units produced. And again, if I want to understand graphically what this looks like, I give myself an X and Y axis and I label them so I know what's happening. On the X axis, I have number of units, and on the Y axis, I have total cost. The equation's a quadratic, so I know it's a parabola. And this time the lead coefficient is positive. And so I know this parabola would face up. And I really don't know if it crosses the x-axis or what happens. I'm just giving myself a very rough sketch so I know what to go look for when I want to answer the questions. So then it says, how many units should be produced each day to yield a minimum cost? So when I dissect this question, the question part is how many units? So I'm translating that in my head when I look at my axes and I see the x-axis is number of units, that I'm supposed to find x. And then my question is, what am I finding x for? A certain y or a certain position on the parabola? And so it says how many units should be produced each day to yield a minimum cost. So I'm specifically trying to find x at the minimum cost. Cost was measured in y, so when they say at minimum cost, this means I want to know what the x is what the x is at the smallest y value. And in this parabola, the smallest y value, the minimum, is at that vertex point. So remember, again, that vertex point will give you the minimum, but it has both an x coordinate and a y coordinate, and I need to understand that when I find the x of the vertex, I'm finding the number of units that make the minimum. When I find the y of the vertex, that's the actual minimum cost in this scenario. So again, considering it said how many units should be produced each day for the minimum, I'm really focusing on finding the x value of the vertex. And I can either do that in the calculator or again by using the negative b over 2a formula. Okay? And if you want to see that specific solution, again, look at the skill 4 solutions to homework. But this just gives you another idea of really how to translate the equation, understand what each variable means, and then interpret that when you're solving the problem. All right, the last thing that we're going to look at here is this system of inequalities, totally different idea, but still using quadratics to see what this should have looked like. So this is from the quiz. And so I'm going to kind of go along with your work here. So we're just going to check the graphs first. So for this equation here, I see, or excuse me, inequality, I see y is less than or equal to this quadratic. You did negative b over 2a really nicely. You plugged it back in. And you got 0, so that looks pretty good. So here's your 2, 0, and you're right about this quadratic being downward facing. Your y-intercepts are correct, so this portion looks good, and I like that you made that line solid. Now, it says y is below this, so our shading would be here. And remember, you can make that decision two ways. You can understand that that boundary cuts your graph in half, and you can literally put your pencil on a y value and say, I'm looking for y values that lie below this boundary, and without moving horizontally, just move vertically to the lower y values, and you would see from any point the portion that would be shaded. The other option is that you can test any point on the graph and you can see if it makes that inequality true or false in order to decide if it's part of the shading or not part of the shading. Okay. I'm going to change colors and we're going to look at the second graph that you created. So the second graph here says y is less than x squared plus 2x minus 8. Your negative b over 2a looks good again. So you got negative 1 as the x coordinate of your vertex. When you plugged that back in, this work looks good. So you got negative 1, negative 9. Your y-intercept looks good. So this graph looks good. And then it's less than. So again, you have the same options for figuring out which area should be shaded. And so it should either be that you can sit on the boundary, pick a y value, and go to y values less than that, or you can plug in a point and test whether or not it makes the inequality true. So when this is done, it looks like our shaded area should be here. Okay. If you're a little bit uncertain, you could test a point in there also. So like, let's say I pick 3, negative 4, that point's in there. And I can try it in each of the inequalities and see if it makes sense. And this would only be if you have extra time and you're feeling like something's just not right. So I'm double checking this because of the question that you asked. And so then when you look at this, it works in the first inequality, and then I would check it in the second inequality, 9 plus 6, 7. It works in that inequality as well, so that seems like a good place for the solution. So I think on your graph, the issue that I'm having is which portion was the overlapping one. It seems like there's lots of areas that you left shaded, some that were both inside and outside of this parabola, so I think I was a little bit confused. If that was my fault and you can explain to me where that shading was and I can see it on your paper, then bring it in. And then with your solution here that you chose, You chose -1, -9. I just want to point out to you where that is. You basically chose this point right here. The reason that that won't work is that point is on this parabola. So when you plug that in, if we plug in -9 for y and -1 for x, you're going to notice you get -9 is less than -9, which doesn't quite work because there's no equal to included in the inequality. So you shouldn't pick a point on the boundary unless both lines are solid, because in that case, both lines include that point and it will work in both inequalities. In this case, that line was dashed, so even though it's right next to the shading and on the boundary, it's not included because it doesn't work in that inequality that's actually the boundary that you picked it on. So that discusses the shading as well as the answer. So let me know if you have any questions on that. Email me back again, and then I can go back through it.